It too.
Well,
Nice.
if I'm wearing a suit, I wear a watch, so that's why I have
Yeah.
kind of like cufflinks. Gotta have them if you need them.
Okay.
All
Well,
right.
I'm gonna start if that's all right.
Sweet. Yes. Everybody knows Brendan, right? It's Brendan. If you don't know
I don't.
Brendan,
I'm a graduate.
he's a
Yes.
graduate, alum from UT, very fluent in C++, very fluent in C++. Ask him any C++ question you want. He probably knows it or knows where to find the answer.
What was the original name of C++?
C with objects? No, that's a. I'm not sure.
Gotcha.
Ah.
See you
I'm not the
classy.
one who claimed to know everything about C++. Josh was, so don't blame me.
Now I'm not
All
looking.
right, maybe I over exaggerate your knowledge of C++.
Just a little.
All right. Anyways, so yeah, he's gonna give his presentation. Do you want to lay down the how you want to give the presentation, the ground rules, Brendan?
Yeah, of course. So last time we had a lot of questions in the middle of the presentation, so I thought that I would try to create designated breaks for questions that are pertinent to what we were talking about. And then at the end, we can tangent and talk about literally anything that you guys want. So keeping things focused, but also providing breaks to make sure everyone's caught up and understands what we covered. Because I think that we didn't handle that extremely well the first time. So yeah, if that works for everyone, let's get started. I think a good start would be to kind of show what our target is. And so the idea is something that I tried to make was super simple so that we could go from start to finish. So this isn't going to be anything complicated. We're not. I actually think that saying that it was a programming language was probably a little bit wrong. It's not Shane. I'm sorry, I don't know your real name. Said that
It's
it's
not
probably
Shane.
more of a markup. Well, that's I guess not wrong.
Kyle. My name's Kyle.
Kyle mentioned that it's a markup language. So my goal is to be able to create a document generator. So let's think of if I'll generate a homework problem is what I'm going to try to make it as. So something simple, of course. The area of a square is 12 times square of 12 meters wide is, and then I want to be able to define code in here to execute and actually allow us to generate the code. So this document, and sorry about my view, I like having the symbols. I'll make it's cleaner without them. The goal is to have that produce the code that would be the same exact thing, but it would replace any code segments with the result of the code. So it would replace this with 144. And the way that we're going to do this is by taking this and processing that and stripping off some of the brackets and processing this as Python. So we're just going to run this in a Python. That's why it's not a programming language. We're not handling the variables and anything like functions or anything like that. We're just handling the structure of the document and processing that, and then handing it off to Python to do the rest. And so the goal is start with this and be able to generate this. So with that, I thought that we could start with showing where we were before. So let me bring that up. One sec. So I don't know if anyone remembers the last lesson. It was like a year ago, so I'm going to assume not, which is why I'm starting with where we were, and I'll try to explain it. So the last time we created a simple grammar where we had a document was defined. Well, how about we start with the Lexer? So these are two separate stages, basically. text was defined as one or more text elements. A text element was something that was not a left brace or backslash, or it could be a double backslash, or it could be a backslash and brace. Basically what that's saying is you can type anything you want, but as soon as you type a brace, this text segment would end because it will not include that. But if you do want a brace, you would have to say backslash brace. That's not a brace. Backslash brace. And so if you basically you're escaping this brace. So that is how escaping, for example, like if you were trying to create a string in Java or C++, and you had a line and you wanted a new line, you would have to type backslash n. So that escapes the n because you don't want a literal n. Where here we're escaping this because we do want a literal brace. So a little different, but that is what that is for. And then we have the code segment, which says a code segment is going to start with a brace. It's going to contain absolutely anything, and then it's going to end with a brace. And this was extremely simple, and I wanted to improve upon it a little bit. So we're going to create a slightly newer version of this. So let's do that. So just as before, one sec. Just as before, we need to create our grammar. So homework generator. Help if I could type. We need our document as well, just like before. Well, again, let's probably start with the Lexer. So text, as before, is going to be one or more text elements. So the plus means one or more. And then a text element will be not the brace and backslash, just like before. But one difference that we're going to have is that instead of having a backslash, double backslash, allowing that, we're just going to have the brace, right brace. And this is just for simplicity. And then we've got our code segment. And here I wanted to change things up a bit. So with the previous one, we only had a left brace and then it ended on a right brace. But the problem with that is that that means in your Python code, you wouldn't have been able to define anything that contained a right brace, or it would immediately end the code segment. So for example, if you wanted to create a variable that was a dictionary, this would not be allowed to exist because it would start with the left brace and then it would end here. It would misinterpret this as the ending of the code segment where we would want it to be here. So what I did instead was to say, make it a tiny bit more complicated by saying require a left brace and a paren, then have your code body, and then have the ending, which is a right paren, right brace. And this allows you to write this Now, the only thing that you have to worry about now, and there are better ways to handle this, but again, I was trying to keep this relatively simple. If you were to have, let's say in here, a value that was a function, you were calling a function to return a value, this would still terminate. But thankfully for this example, it's easy enough to do this, and then you can just bypass that by putting a space in. Not a great solution, but it's a simple one. So I think that that will be perfectly fine. And then we need to create the code body segment because we have specified that up here. So a code body would be not a right paren. So anything that's not a right paren. So this could contain literally anything as long as it's not a right paren. Or it can be a right paren as long as it's not a right brace. So hopefully that makes sense. And then not a right brace would be not a right brace. So not, and then in the set of characters, and not, and brace, right brace. So does that make sense to everyone? Can I explain anything in here better? I am going. Of course. So this is called the Lexer. And what it does is it goes through your document and it will parse it into tokens. And so we need to recognize certain tokens. And so I decided that text tokens and code tokens would be the two tokens that this would recognize. And so how do you identify that? This tells you what to recognize in the form of a regex. And so these are just regexes to recognize specific sections. And so we've got our text section. This is part of the document of the text section. And then here, this is part of the code section. So this would be recognized as code. This would be recognized as text. And so we're just trying to tell it how to recognize what each part is and where it starts and ends. So it's going to start at the first character and it's going to try to figure out which one it is. And so it's going to say, well, text is some text element, one or more. Well, the first letters. So it's going to come down here and say anything that's not a left brace or backslash, which it's not. So it says it'll accept on that character. This one, it'll come down here and say code. Code starts with a left brace, and it'll come here and go, well, nope, it's not code, so let's only look at text. And then it'll process the text until the text says it's done. And the text will finish when it gets through this 2 new lines, and then it hits this right left brace, and it'll go, oh, I don't do that. Or sorry, this one, I don't do left braces. And so it'll stop there and say that this is a text token. So that is the purpose of the Lexer. Was that a good enough explanation, Josh? Okay. So the next thing we have is the grammar, the parser, and it's a little bit easier, at least for this example. So we have our document, which contains text or code. And the reason that I'm saying text or code is because our document we could start with a code segment. We could start right off the bat with a code segment. But we could also start with text. So it needs to be an or, and we want any number of them, 0 or more. And then we need to find the end of file. So our document starts with any series of text or code, any number, and then ends. And so now we just need to define what text is, which I'm just going to say it's text. And then we need to define what code is, and that is code, which refers to the element down there. We could just stick the text element and the code element as these, but I thought it would be a better example to show how a parser actually can be multiple elements. They're hierarchical. So this is telling it, once it creates those tokens of code, text, code, and then if there's text after, it has those tokens, and now it needs to parse them into something called an abstract syntax tree. And so this tells it, this is how I organize these tokens, and these are the possibilities of what you can do with these tokens. And it's basically exactly like the regex that you'd use here, except it's hierarchical, meaning you can have something in a something in a something. With a Lexer, it parses this code and then it's done. With a parser, you can have a thing in a thing in a thing. Think of HTML and how you have the code segments you can have a button in a pane in another pane. And that is perfectly fine. You can't do that processing in a Lexer because it just goes one by one and tells you what they are, what type they are. It doesn't tell you how to organize them. So the parser is telling you how to organize the top level thing. And in this case, it's our document. So that's the purpose for that. So if I get rid of this, this is going to be our grammar. And this is as defined by Antler. So the program that we'll be using is called Antler. And so this is specific to Antler. There are other applications that you can use, and they would have their own ways of specifying it. Next, now that we've seen our grammar, I just wanted to show what a grammar of a real programming language would look like. And I think the best example of a complicated grammar would be C++. So I am going to bring that up. So what this is doing is I compiled the C++ grammar, and I'm telling it to run this debugging code on the grammar so that we can type. Is this visible to everyone, by the way? This window? I can expand it or move it into the center if that's easier. Okay. And so in here, we can type some C++ code and see how it evaluates it and turns it into the abstract syntax tree that I was talking about. And we'll get to see that, a graphical view of that, because I think that might be a better way of showing that section. So I'm just going to create a simple function, void foo. Let's have it take int a and standard string b. Then it's going to do b equals foo a, and something, or I'll do bar so that we don't use the same name. And when I hit Control Z and enter, it will process that. If I did it correctly and said to produce a GUI output, that would help. I think I've forgotten that every time I've done it. Oop, forgot the semicolon. Gonna have to put it on the next line. C++ is white space blind, so that works. And then do that. And it is going to, hopefully, there we go, parse it into its grammar. And before I show you that, I want to show you real quick. Well, yeah, I'll show you that first, sorry. Hopefully this is visible. But C++, our top level was document. Its top level is called translation unit. And so it created a declaration sequence, and that declaration sequence contained a declaration. That declaration happened to be a function definition, and the function definition had a declaration specifier sequence of void, and a declarator of foo with a parameter of int and a type of a name of a, comma, and another one of standard :string with a type called b. And then it's got the function body that has the b equals bar of a. You can see that it's fairly complicated, but this is what would need to be done for something like C++. Not something I want to do. But I thought that it would be a good example to see what a programming language, a modern programming language like C++ would have for being able to process your input for a function. Because it seems relatively simple when you see it in the command. Like it's one function right here, but it has to generate this entire tree to be able to process your input. I just thought that was an interesting aside. And I am going to also show you two things. This is the Lexer and Parser for that grammar, that C++ grammar. So this is the Lexer, if you remember, that creates tokens. And I'm not going to go through it a ton because it is extremely complicated. Things like this simple stuff like class, which will find any instance of class and create a class, and const, which will find any instance of the exact word const and create that. So those are the reserved words that you can't use as variable names and other things like that. And then it has a parser, just like we did, that's a lot more complicated than what we did. We had 3. This has, well, 800 lines. So I just thought it'd be interesting to see what something like C++ would have for its variant, its language, and how it parses it. So now that we're on our language, let's debug our language. So if we cd into our, and then first of all, I want to show you, this is our workspace, and this is the grammar that we just created. Right now, the only thing in here is the Java development kit, just because I didn't want to deal with having different versions of Java and having it, whether it worked or not, because there's compatibility issues with specific versions of Antler and specific versions of Java. So I just used the one that worked, and I stuck it, embedded it in the repository, made it easier for me. And then there's the scripts, which has the Antler library, Java library, and then the scripts that I made just to process it. Though they don't contain much. As you can see, this one's just a single line that just tells it to compile our grammar. And then it's got an output folder for both Java and Python. And Java is used to debug your grammar, which we will use first. And then Python is what we're actually going to be generating to program in. And so we'll get there in a bit. But I'm going to open up the Java and then run Antler and tell it to compile. What did I do wrong? It would help if I remembered to put semicolons in the right place, just like C++. Still a stickler for semicolons. Boom, boom, boom. Okay, perfect. It generated these files right here. So it generated all the Java files, and then it compiled the Java files. So if we look here, this is a Java file. It generated this automatically. We didn't have to write this code. It automatically generated it for the parser. So we specified the parser here, and then it generated a Java document for actually doing the parsing, which is really neat. And that's the power of Antler. Instead of trying to do all of this yourself and parsing the text manually, it automatically generates this code to parse it for you, which is really nice, and create that abstract syntax tree that I showed you. But now that we've done that, we can also do grun, which is the debugger. And we can do our top level thing was called document. So we'll tell it to parse a document and GUI. And so now we can do this on our own grammar instead of C++ and say, this is text, blah, blah, blah. And then we can have a code segment as like we defined before. I'll just stick with the 12 times 12 from the previous example. And then Control Z and enter, and it should process that and create our much simpler abstract syntax tree. So we've got our document, and it contains a series of text and code, and then an end of file. So just like we told it, we want a document to be some series of text and code, and then an end of file, it created that. So we've got our document, contains text. This is text, code, the 12 times 12, and then more text of the new line that I entered, and then an end of file. So this is how you can debug your grammar to figure out where it parsed things wrong or where it is tripping up. Because sometimes if you, regex is not very forgiving. And then making it recursive using a parser makes it even worse. So it's very useful to have this graphical interface for viewing what's going on. I've definitely used it. So now that we've covered that, does that make sense up to here? Does anyone have any questions before I continue? I am going to take that as a no. So the next step would be to actually use this. So we have that abstract syntax tree that I mentioned before, but we have to actually do something with that tree. You can't just have a tree. It doesn't do anything. So what we're going to need next is, well, we're doing Python. So I'm going to create a Python file called homeworkgenerator.py, and we will edit this one. So what we need first is let's import sys, and then let's create a main. So main, and then Python is done in a specific way. So you have to call main, you have to do if name equals main, and then we'll call our main with the reason we imported sys was so that we can have sys.argv. Okay, and then we'll go back to main. So what does our main need to do? Well, first, if you remember, the first thing it needs to do is do the lexing, the parsing it into tokens of text or code. And so we're going to need to have a lexer. Well, where do we get our lexer? Well, we've got, wrong folder. Our output, put Python files, and we've got a homework generator lexer right there. So this is what we want, and I'll just show you real quick. It generated this Python code for us to generate, and this I believe is a state machine. Not sure entirely how it works. That's sort of internal to Antler. You don't need to worry about being able to deal with it directly, so it's not important, but it's cool that it can generate that for you. So we need to have that homework generator lexer. But we need to give this lexer something. So what do we need to give it? Well, we need an input stream of a file. It doesn't have to be a file. It can be any stream, but we'd like it to be a file. So I'm going to say input stream equals file stream and give it that first argument from the command prompt that we got from the system.argv. And the reason it's the 1 index and not 0 is because the 0th one is filled with your path variable. So we ignore the actual first one and go to the index 1. So then we have to give it that value. And then the next thing, we've got our Lexer. It parses things into tokens. And so now we've got a bunch of tokens. So we need to create a token stream. So Antler has a way of doing this called a common token stream. And you just give it the Lexer. And then now that we've got a token stream, we need to give that to the parser to tell it to form our document. And so we are going to give it a homework generator parser, the stream. So now we've got our parser that took that stream of tokens, and now we need to actually do the parsing. And so, and create the abstract syntax tree. So here's our tree, and we're going to say, tell the parser, parse the document. Now what's interesting, and I think is really cool, is this function right here is for us specifically. We called this document. If we called this something else, we would have to call it a different function. So it generated a function for us depending on the names that we specified here. Because we had document as our top level thing, we're going to call the document. And then that is the beginning. So first of all, how do we actually access these things? The problem is that these files are actually located in a subdirectory. So first we're going to have to import them. So first I'm going to import Antler stuff, generic Antler stuff, which you do have to install an Antler 4 package for. I'm installed Antler 4.8 because that's the version of Antler I'm using. And I'm just going to install everything from Antler, import everything from Antler. And then I'm just going to have this. I'm cheating because it takes a long time to type. And so we've got our Lexer, and then we also need our parser because we want to be able to use the parser. And then there's going to be a third one called a visitor. So this is how we're going to actually use that tree. So there's two options when trying to traverse that tree and process it. There's a listener and there's a visitor. A listener says, it tells Antler, traverse the tree and tell me every time you enter an object and every time you leave it. And it will do some processing, and it has at each of those stages. You can decide what to do. What we're going to be using is a visitor. And so what we're going to say is, we're telling it, I want to visit this thing. And then you can tell it, I'm going to visit its child. I'm going to do this. And so it's more explicit about how it works, and it's more powerful. So this is what I had done with my own programming language that I've been working on. So I just used it for this one as well because of the fact that I had familiarity. So now we need to take that tree and we need to create a visitor. So visitor equals homework generator visitor. And then we need to tell it to actually do some visiting. So we're going to say our result equals visitor.visit document. Now, just like before, this was our document that we defined in our grammar, and it defines these functions for us. So because of the fact that we called it a document, it's not going to visit document. And you'll see how that works in a bit. But that is generated code specifically for our grammar. And we need to give it our tree that we parsed. So this is telling it, visit the document that this tree specifies. So this tree is going to specify a document, and I want you to visit it. Now, up to this point, we're calling stuff that Antler handles, but at some point now we need to actually handle that ourselves. So when we visit document, Antler has a way of handling visit document where it's basically just do the normal thing, which is do nothing. So visit document as of right now will not do anything. We need to tell it what to do. And so we are going to create a class called homework generator visitor. And we are going to extend from the visitor class. And I'm going to rename the visitor class to HGV, as in homework generator visitor, just so that I can call this one homework generator visitor. You don't want them to be called the same thing. So I'm going to extend from that class. And then we need to define a few functions. So the homework generator visitor, if we open up that file, it defines a few functions. It defines visit document, visit text, and visit code, the three things that we have in our parser. So we need to also define those three functions. So we will create a define visit document, define visit text, and define visit code. And the parameters that it takes is itself, because it's an object, and the context of the parsing. Right now I'm just going to say pass. Put insert on. So now let's start, I think, at the bottom. I like starting with bottom up when implementing it. Text, I think, would be the easiest to start with. So the context object has a function called get text. And what this will do is it will take the text object and get its text. So in the case of us defining a document and saying this is text, blah, 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 it will give you that literal text, which is exactly what we want. So from visit text, I want to return the text, just straight up the text, nothing else. From the code, we're going to do something a little bit different, and I'll get to that in a sec. For right now, I'm just going to return code section. And then we need to visit the document. So the document contains multiple things. So the text is just text. The code is just text, is just code, sorry. But the document can be text or code, and it's a set of multiple, up any number, 0 to infinite. And so we need to have some way of handling those multiple. Well, thankfully, the context also allows you to access its children. And so you can have access to that in Python. And this is a list of all of the children that this context has. So the document, any children that it has of text or code will appear here. And so what we can do now is we can take those and we can say for child in context.children. And then this is a way of creating an array, a list in Python from a for loop. And we can say child for child in child. So this will create an array of the children in children. But we don't want an array. We want to have the result of the child. So this is going to return text. This is going to return different text. We want the actual text. So it's returning that text. So let's do child, sorry, self.visit and give it the child. So what this says is it says, call the function, whichever one I'm supposed to, it will figure it out automatically. Call the function for my child. If that child is a text child, it'll call visit text. If it's a code child, it will call visit code. It does that automatically for you. And that's provided by Antler. And then it says return whatever result that is, text or different text, and append that to the array or the list, Python list. And so this will create a list of all the results that we collected. And so if we just return that, we now have defined a homework generator visitor that has all the functions that we need. So now let's get back to the code section. So right now we're just returning the string code section, but we need to actually do something. And so Python has this really nice function called exec. And so if we have exec, Python allows you to type in code. And how about I pull up the command prompt here? And we'll just go to Python. And then if I say exec, I can then give it a string of, I don't know, a equals 5. And it will execute that. And now a equals 5. So we gave it a string and it interpreted it as something. This is what we're going to use. Can you work? Thank you. To process our code sections, which is why I said that we're not going to be doing the processing. We will process the document to section out the different things, but we aren't going to be handling the actual code. Just because I wanted to try to keep this grammar relatively simple. And so if we have this exec, can we put in this? Well, let's give it the text of the code. Well, that's not quite going to work because the way we defined it, it starts with a left brace, right left paren, and then ends with a right paren, right brace. And so we need to strip off those characters. So if this is the Python syntax for, what's it called? Array, I'm forgetting the term, striping or something, where you can tell it specifically which indexes you want. So I want to start at the second index up to the second from the last index. And so I can strip off the first two and the last two characters using that. And then I'm also going to do some other things and then explain them. So we don't want different code sections messing with each other. We want them to be independent. So by saying empty dictionary here, we're telling it, don't allow it to access anything that's global. And also anything that it does create, give me access to those objects so that I can do some processing on them afterwards. And so now what we can do is try, and we're going to return a string of return object of result. And I want to try to explain this because it's a little bit weird. And so what this does is it says, if you create any variables, so let's enter the Python thing again, an exec, and we give it some, let's create a random object first. There we go, and then say exec, and say a equals 3. And then say, just like we did in our code, blah, blah, object. Now, if we look at object is a dictionary that contains a, because we defined a in here, and it contains the value of 3. So this is going to store all the values that you used in this exec call. And because of that, we can now access them outside of that exec call without it interfering with any of our variables. And so what we're doing is we're saying, if you create a variable called result, we're going to take that, turn it into a string, and that's going to be our result. So the code, if you remember, our goal was to have something to the effect of 12 times 12, and it would return 144. Well, what we're actually going to have to do, because we're using Python and not creating something ourselves, is say return or result equals 12 times 12. And because of the fact that it will look at the value of result and turn it into a string, it's going to return 144 as a string. And so it's going to handle that for us now. And so that code will now do exactly what we want for turning code into a string of the result. So next, what we need to do is I'm just going to say print result. So we tell it to visit the document. When we visit the document, we traverse all the children. When we traverse all the children, we return whatever they're supposed to return, and then we get a result. So I want to see if we can access that, and let's see, workspace. Let's call the homework generator.py. And so in here, we tell it we need a specific file. So first of all, let's create a new file that's just called test.hg. HG will be for homework generator. You could label it whatever you want. And so we're going to come down here and say test.hg. And we're going to look at the result. Well, that was a bunch of nothing. What did I do wrong? Oh, yes. So if we don't have anything in it, it's not going to process anything. So let's first edit that to include this is part of the document of the text section. And this is going to be code, so we're going to say result equals that 12 times 12, which is Python. This can be any valid Python code. And I'm actually going to align it to the left because Python will need that. So if we save that and then run it, it's still printing nothing. What did I do wrong? Well, saving the document, I'm sure, would help. My bad. Forgot the whatever. Sorry about that. So our return object, we need to define it as something, initialize it as something first. And then we got it. So this is part of the text section, new line, 144, and none. Now the none is coming from the fact that at the very end, we've got an end of file. And so when it visits that end of file, it doesn't return anything. And so when it says visit that child of end of file doesn't return anything. So that's why it says none. So now we are able to successfully parse the file and produce a result and use the exec function of Python to actually execute code in our document. And so at this point, all we need to do is create the output document. So let's do that. Output file equals. And what I'm going to do is I'm going to create an output file that's the same as the input file, but appends .hw for .homework. You can, again, do whatever. This isn't specific. It's just an easy way of handling that. We want to open it for writing. And there's some weird things with new lines. So I found out that you have to tell it to not add extra new lines. Otherwise, it will add extra new lines. And so now we need to go through our result, which our result, if you remember, is a list. So we're going to do a for each loop, or a for loop, for thing in result. I'm not very specific. And then we're going to get rid of that none object so that we don't have to deal with that. So if none, and we're just going to, well, actually a better way to do that would probably be to do if thing does not equal none, and then just say output file dot write our thing. And then if we want to do debugging, I guess we could do that. And then of course, always, always, always close your files. This allows you to edit them. If you keep the handle on it, no one else could ever write to the file until you release it. So you always have to make sure to close your files. And there's better ways of handling this in Python. There's some using syntax, but I wasn't going to go into there. And ignore this. This is for debugging. So now that we have this, we can say for everything in our array of results, append that string. And because of the fact that this is what we input, we should be able to execute this code and have it generate an output document that's test.hg.hw that contains the exact thing in the input file right here, but replaces the code segment with 144. And if we open this up, boom, that's what we have. So you can take an input document, and let's just say, I'll change this to the area of a square with side 12 is, and if we go back and regenerate, this one got updated and it updated to that. So that is how that works. I think that's pretty cool. Does anyone have any questions about this? Probably should have stopped partway through, I think, but better late than never. Well, I was thinking of an idea of like, so do you know how much effort Nolan puts into making homework problems, custom problems for, he'll generate 3 different versions of a test so that he can have a good test where he can have variation between tests to find cheaters, and he makes sure to make it custom to the class so that he knows he's pushing the class to its limit but not over their limit. He does an amazing job with his tests, but he rewrites them every single time. And I was thinking if there was a way to sort of store those, generate random things, and be able to have a homework generator, I was like, that'd be pretty interesting. I don't think that this would be possible to do easily enough. And if I made it, I highly doubt that Nolan would even use it. But that's where the idea came from. A concept like that, because it'd be nice to let him spend all his effort teaching and not creating tests that are brutal and kill you and his take-home. If anyone's new student here, have fun with his take-home tests. They are brutal. Well, that's statics. I've heard things about statics. I'm not sure. Yes, DLD. Great class. Nolan is an excellent professor. Highly recommend taking any class that he does. But yeah.
Yeah, supposedly he said he's like lightening up on stuff.
Okay.
I took 2 classes with him last semester and it wasn't too bad. But that was DLD and statistics.
Does he have any of the main campus students in his class? Because I'm sure that would also make things more difficult.
He did in DLD.
He does.
Because I don't believe he needs to, at least not consistently. So yeah. But so something like this would be useful. Allow him to still create a bunch of different versions and then compile them all together. But as I said, I don't think that this is a project that could actually take off. That's just where the idea came from. Yeah. Put the answer. And so, well, the way that I was viewing it this was just for the problem, but I was kind of viewing it as having random sections. So you'd say something like, you'd have actual code instead of this being more just defining different sections. And so you could say, I'm going to just put this, but that would be I'd use a different syntax, but something like random1 equals, and then be able to say some value between 1 and 100, random2 equals some value between this is a weird syntax, but some even value between 1 and 100. And then being able to say, or really that'd be 2, but, and then being able to use those results and say, area of a square with side, and, 1 of a and this isn't a great example, but being able to create randomizers, I don't know if you could have a class in Python or create a way of specifying ways to create different things that are random, and maybe from a given set, maybe from a given range, maybe from a whatever, and then being able to say, I can generate anything in here, and then have our program look at random and generate multiple. So you could tell it, hey, I want to generate test.hg dash assignments 10, and it would generate 10 different assignments, each with different problems based on generating different random numbers for each assignment.
And you would also get the solution along with it.
And you could have it generate both the homework and the solution, because you wouldn't print the result. It would fill in something else for the result. So you could have even something like this, where it'd be like ants were, and then or solution or whatever, and then it would not print this in the student's version of the generated text. There's a few problems with this as an actual concept. One, you'd use something like Word, because you can't have pictures in this. You can't have diagrams or anything like that. You need it. So this would not be viable for an actual thing. It's just text. You might be able to do some things where you have ways of specifying picture, and then I don't remember HTML, so don't kill me, but and then being able to say like a file dot png to specify a thing on the picture, and then maybe specify properties in that section, so that you could have it generate homework or maybe generate a Word document. I don't know if that's possible. I don't know how hard it would be to generate that. Hopefully there'd be a library for something like that. But if it was going to be anything close to real, this is the sort of thing that would be necessary.
Okay, makes sense.
So, yeah. Generate a solution guide, generate different random things, being able to specify something that's persistent among all of them, because as I mentioned before, code sections are only between specific code sections. So you don't have access to you do not have access to any of the other code sections variables. So being able to have a shared set of variables, so you could specify shared variables and then declare a bunch of variables in here, with default values or something like that, so that they'd be shared between different code results. You'd need something as powerful as that to be useful. I think it's doable, but it'd require a lot of work, and to be honest, I don't think Nolan would would even use it. So
Right.
I don't think it'd be worth
It is a
working
cool
on. But
idea,
I thought it'd be a fun. Is that a Joey? He said he was coming in late.
Oh yeah, here
Sorry,
it is.
yes.
Hey, I'm good at predicting things. You said 30 minutes late.
Well, the Bible study went long, okay? I didn't know.
Okay.
Sorry.
Do you
Sorry,
wanna-
Dad.
Do you wanna? Could you? Do you think you could do a quick like 5-minute summary of what you just said?
Just start over.
Don't start over. I always like to have a
Let's start
summary at
over.
the end, but if you don't want to, that's okay.
No, I think a summary would be a good idea. Let me just get rid of some of these things. So the goal of the project, let me just get this back to where it was. Is to be able to process a document, something like this, where you have some input and then you have some output of a document that would be generated off of this. And so in this example, we have this text that's here, this code that's here, and we need to be able to parse it so that we know what a text area is, what a code section is, and then be able to generate this result and do a replacement of this section, not what I meant to do, with the actual result. And so the way we have to do that is by using a Lexer to do the lexical parsing, which will turn the document into a series of tokens that are groups of characters. So we've got our code token and our text token, and then you use a parser to take those tokens and compile them into what's called an abstract syntax tree. And that tree, I don't know if I can, probably not going to do that, but that tree will allow you to access the way that the document's constructed as a hierarchy. And once you have that, we need to generate code. And so we created our homework generator.py, which took the file, gave it to the Lexer, took the Lexer, gave it to a token stream to take the tokens and put them into a stream, made a parser from the stream of tokens, and then told it to parse that document that we specified in our grammar, which created the abstract syntax tree. And then we need to create the visitor that will visit that tree. And so we tell it to visit the tree by starting on the document, because that's our highest level concept, is a document that contains other things. And then when it gives us the result that we specified in our class that we extended, we process the results by just printing them to a file as strings, since they were returned to us as strings. And then we close the file and we produced a result that is the exact thing that we started with the code replaced with the result, just like we wanted. And so that is how a programming language works in a high-level concept. And yeah, that's sort of the summary. To sort of talk on the differences between this and what I would consider a real language, like something like C++. Something like C++ has something, instead of doing it by document, it actually does it by what's called a translation unit. And a translation unit is all the files that are from the starter file and all the includes pasted in. So basically it goes through your file, and if you had a main.cpp, and that file contains stuff, if it contained an include of IOStream, and then you have your void main whatever, it would first copy and paste this file in, and any files that it included in first. And part of that is also involves the preprocessor, which handles what gets pasted in based on what's defined at compile time. It's some complicated stuff. It's convoluted. But there's a bit more to it than just a simple document. It's not just looking at just the text that you did. And at the end, it produces something that's actually able to go onto the back end, what's called the back end of the C++ compiler. And it will then create multiple optimization loops for your code, and it turns it into object code, and then it can compile it into an executable. So there's a lot of stages and steps involved, and we don't really cover that in this example, but I still thought it was a good example of starting from nothing to going to being able to process a file and produce an output. Technically, that's still a compiler of some sort. And I had fun with it, and I hopefully everyone else did too. So yeah, that is all I have.
Awesome.
If there's any questions or comments or anything, I'll answer anything.
That was cool. I like your funny words, Magic Man.
Thanks. But yeah, like Joey, tell me to type some text of a homework problem that you want to generate.
Okay. Nolan has 3 cats, and
Nolan, not Nolan.
Nolan. It has a W in it, I think. He has 3 cats and 2 cows. And then in total, he has how many legs of animals? How many animal legs? Oh, snap.
Okay.
Oh, Nolan is IN, not AN also.
Correct,
Thank
kiddo.
you. Spelling is not my thing, you know.
Hey.
As
It's
long as
fine.
you're consistent, it doesn't matter.
Yeah, it's fine. I understand.
3 times 4 plus. Oh man, he's doing math. This is crazy.
And then we can tell our generator to run this test.hg file and generate the output and reload. Hey, look, it's 20.
He has a lot of
Oh
legs.
my goodness.
Magic.
Assuming that Python and me did things correctly.
Probably not.
Yeah, you're right. Probably not. But yeah, that's that.
Very cool.
Can I ask a super off the wall question?
I said that everyone can ask off-the-wall questions at the end.
Wait, hold on a second. That's wrong.
What?
That's wrong.
He's
12
wrong, or
plus 8 is 20.
It's 22.
12
What did I
plus
do?
8 is 20, buddy.
Wait.
Nolan has 2 legs.
No.
Oh my gosh. Please. I said how many animal legs was my
That's
question. I
true.
don't know what he wrote down.
Legs of animals.
You've met Nolan, right?
Wow. Okay. Like I can't argue with it, but okay. This so natural language processing with machine learning, usually you just like feed it words and then it creates its own embedding. Do you think that there's some way to use the grammatical structure to improve that concept?
Can you say that again?
So in natural language processing with like machine learning algorithms,
Mhm.
usually you just feed it in text, whether that's like 1 character at a time, 1 word at a time, or like the last 5 words at a time. And then it embeds it into a vector. And that way that vector basically encodes the information of the words. Do you think that it, providing grammatical structure could like improve that idea? Is there like is there anybody that does that? Is that a thing?
I've never heard of that being a thing. The problem is that computers aren't really good at figuring out what that structure is. And with something like this, the only way English doesn't really conform to rules because there's way too many exceptions. So I actually was looking into creating my own language just for fun, like human language. I was like, what is one way you could create one that would be actually computer parsable and easy to understand and consistent. Because think about things like a word being read. It's the same freaking word, but you interpret it based on other things, and you know what it is based on what you know it's supposed to be, based on other context, not necessarily the structure itself. And you can't use something like this for that, for processing that structure, because you would have to have well-defined rules, and with grammar there's just not. Why do you think that Word can't always recognize when something's supposed to be it doesn't always know the grammar? And I've seen some things on, I think it was Software Gore, of
Yes.
having it Google correct their document and say, did you mean this? And then they click yes, and it changes it to that, and then it refers them to the thing they had before, so that it's literally flip-flopping, because it just does. There's rules and there's exceptions, and there's just weird things that happen that you can't really handle. There's edge cases that are literally you can't handle, except for a very unique case where you specify exactly based on that case. And so because of those, there's no hard and fast rules. I don't think you could parse it using the tree and give the machine learning algorithm any other information, unless you created a machine learning algorithm that tells it, the other machine learning algorithm, what the structure is.
That was what I actually, as you were saying that, I was like, well, what if we flip it? And I was hoping you would say it. Interesting. Okay, thank you for listening to my muse or whatever, or answering
Of
that.
course, I enjoy it. But yeah. Well, if there's no further questions, that's all that I have.
Thank you, Brendan.
All right, thanks, Brendan.
Thanks for coming.
We appreciate your time.
Yeah.
I enjoyed it.
I appreciate that you're. Well, I'm not sure if I appreciate the fact that your start menu is on the side, but I appreciate the fact that you can tell that your keyboard is in Dvorak.
Because I constantly mistype things?
No, because down at the bottom it says English and then it's got DV, so you can just switch it when you need to. Yeah, it's nice.
Yep.
How's your
Yep.
Dvorak journey?